Look at the solar system. It seems perfect, reliable, like a clock. For centuries, we looked at the night sky and saw order. We believed that if we knew the position of the planets today, we could predict where they would be in 1,000 years. This confidence came from Isaac Newton. With his laws of universal gravitation, he solved for what we call the two-body problem. If you have just two objects, like the Earth and the Moon, or the Earth and the Sun, Newtonian mechanics works perfectly. It gives us a set, predictable solution. But the universe isn't just two lonely objects in a void. What happens when you add a third one? No. Everything falls apart. This is the three-body problem. It is a phenomenon where the mutual gravitational attraction of the celestial bodies creates an orbit so complex it becomes impossible to predict. It challenges the very limits of our understanding of physics, where the two-body problem gave us certainty. The three-body problem gives us chaos.
This puzzle isn't new. It goes back to Newton himself. In his famous work, the Principia Mathematica in 1687, he laid the groundwork for how we understand gravity. He successfully explained the two-body problem, which unlocked the secrets of Kepler's laws. But even Newton noticed that adding the third body complicated things significantly. He couldn't find a clean mathematical formula to solve it, and for centuries, neither could anyone else. Brilliant mathematicians like Lagrange and Laplace tried. They made progress, finding specific stable spots in space we call now Lagrangian points. But a general solution remained out of reach. It was until the 19th century that a French mathematician named Henri Poincaré changed the game. He demonstrated that the three-body problem couldn't be solved by the traditional math of the time, specifically convergent power series expansions. Poincaré realized something terrifying about the universe. The slightest movement, the tiniest delay in an orbit, would result in a completely different chaotic outcome. This was the birth of the chaos theory.
Poincaré discovered that these systems exhibit complex behaviors known as homoclinic tangles. In plain English, it means that even in a system ruled by physical law, the outcome can be totally unpredictable. This was a hard limit for Newtonian physics. The math that sent us to the moon couldn't fully account for the pure chaos of a three-body system. So, how do we deal with it? We cheat. Well, scientifically speaking. We modify the variables. This is called the restricted three-body problem, or hierarchical triples. If one of the three bodies is massive, like the sun, the second is large, like the Earth, and the third is tiny, like a satellite, we can pretend the satellite has zero mass. Its gravity doesn't pull on the sun or Earth enough to matter. By making these relatively small changes to the problem, we can make the unsolvable solvable. This restricted version is the key to how we understand the stability in a chaotic universe.
You might ask, why does this matter? It matters because we are explorers. Companies like SpaceX and agencies like NASA deal with these problems every single day. When planning a trajectory for a space shuttle or positioning an orbital satellite, engineers have to understand chaos theory. They aren't just pointing at a rocket and shooting it. They are navigating a gravitational minefield. They use these principles of the restricted three-body problem to find stable paths through the instability. They use the very chaos that Poincaré discovered to preserve fuel and slingshots through the solar system. Without understanding these instabilities in the universe, our GPSs wouldn't work, and our Mars rovers would be lost in the void.
The three-body problem is more than just a math equation. It is a reminder of our limits. It shows a clear barrier between human calculation and the wonders of the universe. The two-body problem gave us the arrogance to think the laws of physics were written in stone. The three-body problem threw that certainty out the window. It implies a deep unpredictability in our world.
But this isn't a bad thing. This unpredictability is what fosters our ambition. It pushes us to build better computers, smarter AI, and faster rockets. It reminds us that even in a universe governed by laws, there is still room for the unexpected. The universe is chaotic, but in navigating the chaos is where we truly find our way.
But recently, the story has changed. We realized that if human math hits a wall and if standard computers are too slow to simulate every single variable, maybe we need a different kind of intelligence. In 2023 and 2024, researchers began applying physics-informed neural networks to this century-old problem. Instead of calculating gravity step by step, like a Newton would have, these AI models look at the pattern of the chaos. Traditional supercomputers might take weeks to simulate a complex three-body interaction over millions of years. Deep learning algorithms? They can do it in a fraction of a second. They are learning to predict the unpredictable up to 100 million times faster than our best conventional solvers. We are no longer just solving the problem. We are training machines to feel the gravity in ways our equations never could. This isn't just math anymore. It's the future of navigation.
This stir of unpredictability has split into our culture too. You might have seen the hit series The Three-Body Problem. While it's science fiction, the core premise is terrifyingly real. In the story, a civilization lives on a planet tossed between three suns. No stable seasons, no predictable days, just chaos. It highlights the dark truth: life requires order. We're lucky to live in a two-body dominant system, Earth and the Sun. But if we lived in a three-body system, civilizations as we know it might never have developed. The chaos would have wiped us out before we even learned to look up.
This brings us to the final, unsettling question. Is our own solar system actually stable? For a long time, we thought the answer was yes. But remember, the three-body problem says adding mass creates chaos. We have 8 planets, dozens of moons, and millions of asteroids. Simulations show us that there is a tiny fractional chance, roughly around 1%, over the next 5 billion years that Mercury's orbit could destabilize due to gravitational tug of Jupiter.
It could result in a collision of planetary proportions. It is the ultimate three-body problem, playing out in slow motion right in our backyard. So, while Newton gave us the clockwork universe, the three-body problem gave us the truth. The universe is wild, it is messy, and it is beautiful. And we are just learning how to survive in it.